Now, in section 10.3, as we're solving, well, remember, we have to know our basics, and we know that when we say the word solving, we have one goal, and the goal is get x by itself, or y, or whatever letter they want, right? Our goal is this. We want to know what x equals. And we've already learned that we have to get rid of things in math. If I see addition, I'll do subtraction. If I see division, I'm going to do multiplication to get rid of it. The only difference today is we're going to be solving radical equations. And when they say radical, it just means it's going to have these symbols in it. Okay? Now, we've talked about how to get rid of powers of 2. We've talked about how to get rid of certain other things. Well, today we're going to talk about how we get rid of radicals as well. So, a radical equation is an equation that contains a radical. Well, duh, of course, that's why we call it a radical equation. It's got a radical expression in it. And normally we call it a radical expression if the letter's on the inside. That's what makes it a radical expression, is the fact that the variable we're solving for is going to be on the inside. So you have one step first. The first thing you're going to do is isolate. You need to get the radical. I'm just going to put the symbol, and yeah, we'll throw a little x in there for now. Your goal is to get that by itself. That's what isolation is. Get it by itself. Then, all right, well, think back to something that you've already done. In this class, we've talked about powers of 2. We've talked about quadratics. And we said to get rid of something like this, let me show you. If it says x squared is equal to 9, how do you get rid of a power of 2? Yeah, you're showing me with symbols there, but yeah, you bring in a square root. They had to match because the goal is this will cancel this, leaving me with x. And yeah, over here you go plus or minus 3, right? We do that. But the idea was to cancel out a power. Well, then I need to bring in a radical. So again, even if I do this and we go x squared is equal to 16 now. Again, how do you get rid of a power of 2? You bring in a radical, a square root, because it's got to match. Well, now the question is, well, how do you get rid of radicals? What are you going to have to bring in? What did we say happens with a power and a radical? They cancel each other out. So what cancels out a power? A radical. What cancels out a radical? A power. That's it. That's today's big idea. And so that's why it does say, once you get this by itself, you're going to square, not square root, square both sides to eliminate the radical. So we want to get rid of that little radical, that square root box. So they're saying, if you want to get rid of this, well, then you better do this so that it cancels out. We need to give both sides, and that's what it says here, give both sides a power of 2. So when you're working out these problems, at some point, it's going to look like this. You're going to give both sides a power of 2. And again, put it in your word wall. Remember, your word wall should always be out. But these little symbols, because yeah, it says it in words. But then some of you always ask during the test, yeah, but what does that mean? Well, you should have written something out for yourself. Word walls are there to help you, but you got to put in your part as well. So that's the idea. We're going to be solving. Now, my letter is going to be stuck inside one of these square root boxes. So to release it from that box, that's when we bring in powers of 2. Okay? So here at the bottom, it does say that when you're squaring each side of an equation, if 2 expressions are equal, then their squares are also equal. So what they're letting you know is that you are allowed to give both sides a power of 2. And so, again, they're going to look a lot like this with radicals. But again, all they're saying is if you give 2 sides a power of 2, the equality will remain. That's why it's okay to do what we already wrote here. So I don't really need to write anything else because we already have it here. So it's okay to give both sides a power of 2. All right, let's put it into practice. And again, if you have highlighters, colored pencils, please use them. Visually, it will help your brain make the connection that when you're solving a radical equation, sorry, it's got one of these in it. Well, this one does. So look at the x. It's located inside a radical. So right now it's stuck in there. All right, well, let me ask you this. Normally we used to always put a little line down the equals. We can still do that. So let me ask you this. Is there anything in front of the radical? No. Is there anything behind it? No. So is this ready to go? Absolutely. So the question today is it ready for me to give it that power of 2? Well, we already said there's nothing in front, nothing behind it. So if it's isolated, then it says give both sides the power of 2. And if I give both sides the power of 2, again, what's going to happen to the power of 2 in the radical? It's going to disappear. They're going to cancel, leaving me with just x. And that's always been our goal when we're solving. What does 4 squared mean? There it is. Perfect. You got to know the basics, the meaning. It just means 4 times 4. So what's 4 times 4?
16.
And there's my answer. Notice we don't say plus or minus, not in a situation like this. We're just trying to get the letter by itself. So we're just following what it said on top. But you do have to be careful. You got to ask yourself, am I ready to bring in the power of 2 or not? Okay? So that's why when I look at number 2, give it a little separation here. When I'm looking at number 2, here's the x I'm solving for. It's stuck in a square root. So the question is, am I ready for a power of 2? No. Who's messing that up for me right now? Okay, so good. We have to get rid of the 4 first. Well, how do you get rid of a number that's right next to whatever you're solving for? Careful. Division. Only division can get rid of a number that's right next to something I'm solving. Remember, they're multiplying. So I'm going to divide by 4. All right, well, look, here's our little line down the equals, of course. 4 divided by 4, well, that's gone, leaving me with radical x is equal to, and what's 12 divided by 4?
3.
So there's my 3. So now I bring up the question again. Is it now ready for that power of 2?
Yes.
Yeah, because now it is by itself. So just like you said, I'm ready to give both sides the power of 2, and we got to make sure we show it. So there it is with the power of 2 on both sides. All right, but what am I left with here on the left? That's the whole point, right? We wanted it to go away. And what is 3 squared? Well, first of all, it means 3 times 3, so 9. There it is. Questions or concerns so far? Highlighting, using colored pencils, whatever it takes, helps. Look at this next one. There's the radical x. Put my line down the equals there so that we don't forget. We're trying to move things around. So, is this one ready for a power of 2? No. Who do you have to get rid of?
5.
How do you get rid of the plus 5?
Minus.
See, basics, good. Remember, you got to stick to your skills. You guys are experts at moving things around already. So just keep doing it. So now I'm left with radical x here. 13 minus 5, well, that's just an 8. So now here comes the question again. It's the question of the day. Is it ready for a power of 2?
Yes.
Yeah, now it is. Because there's nothing in front, nothing behind it. So all I'm going to do is give everybody a power of 2 here. And I end up with x is equal to, well, what's 8 times 8? 64. Thank you. There you go. By the way, remember, these are perfect squares, so you can still keep using that list, right? It might be a little bit faster than the calculator, but they are perfect squares. You can continue to use it. All right, let's practice one more and then give you a moment to try some of these out. All right, now watch out for this one. Okay, so for those who already said, no, I already got this, I understand it. Careful. Look, there's a radical x. No, it doesn't have a power of 2. We don't have to worry about that 0. Am I ready to give it a power of 2?
No.
No. Who's in the way? Careful, it's just a 3. The negative is in front of this, right? My concern is the 3. Then how am I going to get rid of that 3? What am I doing here? It can't be division. It's not directly next to it. How am I getting rid of the 3? Subtract it, exactly. Remember, this is a positive 3 in front. You don't look behind it, you look in front of it. So I'm going to subtract the 3. All right, well, now I'm going to make a mistake on purpose. Let me see if you could catch my mistake. Doing it on purpose. Yeah, there should be a negative right in front. You don't make it disappear, it's there. So then my question to you again is it officially ready for a power of 2? No. You still need to get rid of that negative. We want to get rid of everything around it. But remember, that is technically an invisible little negative 1, right? So how do you get rid of this negative 1 that's right next to it? Yeah, just divide by a negative 1. And now we could just make it disappear. So now it'll be ready. And what's a negative divided by a negative? Positive. All right. Is it now officially ready for a power of 2? Yes. So now it is. Remember, isolation means this. Nothing in front of it, nothing behind it. So we give it a power of 2. All right, and what's my answer going to be? 9. Well, x equals, right? But yes, you're right, 9. There it is again. Okay? All right, so here's what we're going to do. You're going to practice these 3. We're actually almost near done with the notes. We just have 2 pages. So you're going to practice these 3, but once you're done with these 3, go to page 7 and do the first 3 from today's classroom. Remember, this is part of your ticket out anyways. So you're basically going to try to work on 6 problems right now. These 3, and then the first 3 on page 7. Okay? All right, let's do 2 songs to see how much you can get done in that time. All right, go for it. Okay, so on page 6, now that you've tried these 3, they're going to get a little bit more complicated. So it looks like we have 4 more examples, actually. You only have to do 3 of them. All right, well, look, it still says they want you to solve. So my goal is get x equals, right, get it by itself. There's a radical equation, just like the answer for 10.1, homework number 1 there. Radical equation. So again, I'm going to highlight. Again, that's what I like to do. There's the x I'm solving for, but it's stuck in this square root. Who else is stuck in there with it, though? The 2 is. So am I going to be able to move the 2 out of the way? No, it's stuck. Right? That one's stuck in there. But there are things that I can get rid of. And they're starting you off with a slightly tougher question here right away. That's all right. We can handle it. I need to get this highlighted part by itself first. So if that's the case, then who am I getting rid of first? Always the 3. We always get rid of adding and subtracting first. So what's the opposite of adding 3? So minus 3. Okay, we'll do that to both sides. And then I have a 4. I have the x. I have the plus 2 inside with it. Equals 19 minus 3 is what, 16? All right, but again, the question of the day. Am I ready for a power of 2? Well, look at it carefully. No. Who's still messing it up for me? So how do I get rid of a number that's right next to what I'm solving? Dividing. Good. So I'm going to divide by 4. Divide by 4. And we end up with the 4's are gone. Square root of x plus 2 is equal to, well, this is just a nice little 4 there. Works out perfectly. All right, well, let me ask you this. Can I get rid of the 2 now? No, it's still stuck in there, right? It's stuck with the x. But the question of the day, am I now ready to bring in a power of 2? See, now we can. There's nothing in front. There's nothing behind it. Remember, that plus 2 is stuck in there with the x. We need to get it out of there as well. So when I give it a power of 2, like we did in the other problems, all right, well, what am I left with on the left side? X plus 2. Exactly, yeah. Everybody finally just comes out of the box. Right? The idea is the power 2 and the radical cancel. Everybody now is available to be messed with. And then 4 squared is just 16. But I'm not done, right? In the other page, I was already done. I still have one little extra step to take. How do I finally now get rid of the 2? Minus the 2. And so I know we're low on space here, but x is equal to 14, and that's my answer. So again, if you end up with numbers that are also stuck in there with the x, well, you can't move them until you get them out with that power of 2. So when I look at this one, now I get it. I know some people have a little bit of an issue with having the y on this side. It doesn't matter. We still solve it the same way. I'm solving for y, but it's stuck inside, and look who else is stuck inside with it. The 2 is stuck in there. The 7 is stuck in there. So am I going to be able to do anything with the 2 and the 7? No, not yet. Not yet. But who should I get rid of? And how do you get rid of this 5? Yeah, minus 5. Basics, good. So then I end up with 5 on the left side. There's the radical. And then the question of the day. The question of the day is it ready for a power of 2? And now it is. Yeah, remember, you can't move the 7. Can't move the 2. They're stuck in there. So let me get them out. I'm going to give it a power of 2 on both sides. All right, what's 5 times 5? So 25 on this side. What am I writing on the right side? Yeah, everybody's finally unstuck. Everybody's out now. Now they can be messed with. So then what's my next step? Yeah, add the 7. Now it just looks very basic algebra, right? Add the 7 to both sides. 25 plus 7 is 32, is equal to 2y. That means there's still an extra step. What's my last step? Divide by 2. All right, has anybody divided this yet?
Yeah.
What is it?
16.
Thank you very much. 16. Perfect. There's my answer. So again, what we're letting you know is if you get numbers that are stuck in there with the letter, well, they also need to be unstuck, right? We need to get them out too. But the question of the day is it ready for a power of 2? Now, hold off on these practice. Let's just do these last 2 problems, and then you could do the other 3 in a little bit. So here again, it says they want me to solve. And yes, there's going to be some radicals in it, is what they're saying. Question of the day is, am I ready for a power of 2? So when I look at this side of the equals, is that side ready for a power of 2? Yeah. But then you notice there's another radical. Well, look at this side. Is that side ready for a power of 2? Yeah. Everybody's stuck. And the only way to get them out of there, give both sides. So this one was ready instantly. Give both sides a power of 2. So don't get thrown off with the fact that there's one radical on one side and one on the other. The question is still the same. Are we ready for powers? And they were both ready. So here's my equals. Let me put my little line down the center here, down the equals. So on this side I have 2x minus 1. And then on this side we have x plus 4. Now this is just basic solving. Now we haven't solved one like this in a while. Remember, what letter am I solving for? X. How many x's should I have? So that's what I have to work with first. Remember, it's the only time, right, in life that we want our x's to be together. So this is 2x. This one is 1x. So which one am I moving over?
1x.
Yeah, we always move the smaller one. So how do I get rid of it? Yeah, let's subtract the 1x. Remember, only in math we want the x's together. So what's 2x minus 1x? Yeah, 1x. And I don't even need to write invisible ones. Minus 1 is equal to 4, which brings me to my last step, which is to do what? Plus 1. And so after all of that, my answer is 5. There it is, 5. Perfect. So again, don't get thrown off. The name of the game today is it ready for a power of 2? And when you see 2 radicals, then ask that question right away. So here we go. Is this one ready for a power of 2? Yeah, there's nothing in front, nothing behind it. Well, look at this one. This one has a 10 and a 3, but they're also stuck in there. So is it ready for a power of 2? Yeah, they both are. Well, then if they're ready, well, bring it in. Power of 2. Power of 2. We bring it in right away. And so here's my little line down the equals, because it does help. All right, what do I have on the left side here? The y. What do I have on the right side? 3y minus 10. And again, do I want to have this many y's written out?
No.
No, but I do need to move it over So I do need some adding or subtracting. All right, well, we know there's an invisible 1 here. All right, which one am I moving? The 1y or the 3y? It really doesn't matter which one, but which one do you want to move? The 3? All right, let's move the 3. You're right, because we should get it away from the 10. How am I getting rid of this 3y? Minus 3y, good. Basic, come on. You guys know your rules. You just have to trust your skills, because they're there, just trust them. So what's 1 minus 3? Careful. Negative 2. And then, of course, I made a mistake on purpose. What was my mistake? That's a negative 10. Don't forget that minus sign. All right, well, how do I get rid of this negative 2? Divide, good. It's right next to the letter. That means only division can get rid of it. And so what's my official answer for this one? 5. Perfect. So again, the question of the day is, am I ready for a power of 2? And if you're not, well, you saw what we did up here, right? You got to move things around. Get it ready for that power. And then you get something like this where everybody was ready for the power. Then give the power of 2 right away. Okay? All right, so we're going to practice these 3. Remember, you still have 3 of them here that you need to do. Get that practice in, and then your next thing, finish page 7. Get it checked, get it signed off by one of the mentors. Mentors, I'll leave my paper out so we can start marking them. And then remember, you got to get homework 10.1 done. That's the priority. Okay? All right, everybody, get to work. If you have questions, let us know. We're here to help you out.